Welcome to Algebra 3. We're in Lesson 6 today. We know that when we solve fractional equations, that a good first step is to find the common denominator and then eliminate it. Once we get everything on both sides of the equal sign to have the same denominator, it's a no-brainer to just go ahead and eliminate that, because we know the step in between finding the common denominator and eliminating it is multiplying everything by the common denominator. So let's jump into example 6.1 to illustrate this. Here's our problem. Now we also know that when we have a situation where there is a variable in the denominator, that we cannot allow the denominator to equal 0. My pen stopped for just a second. There we go. So we know that x cannot be equal to -2. So we have to put that up here to remind ourselves. X cannot be equal to -2 because then that would give us a 0 in the denominator. So we can't do that. So let's find a common denominator of all of these. So if we're looking, we see that we have a prime number here and a prime number here and x plus 2. We don't know what x plus 2 is, but we do know that 7 times 3 is 21. So we're going to multiply everything times 21 times x plus 2 times each individual fraction. So let's do that. We'll have x plus 2 times 4/7 plus 21 times x plus 2 over, or times 3 over x plus 2 equals 21 times x plus 2 times 5/3. And now we eliminate. So we know that 3 times 7 is 21. So then that's going to be left with a 3 here. And here we have the x plus 2 is eliminated. And here we have 3 times 7. We eliminate the 3. That leaves us with a 7. So now we can just do straight multiplication all the way across with no denominators. So 3 times 4 is 12. And 12x plus 24 is what this would give us. Plus, we have 21 times 3. That's going to give us 63. Is equal to 7 times 5 is 35. 35x plus 70, because 2 times 35 is 70. So now we can solve this. But x cannot equal -2. We have to remember that in our result. So let us move the x's and the terms, or get them all the x's on one side and all of the whole numbers on the other side. So I'm going to move my x over here because this is the smaller number and I like to deal with a positive variable. That's just the way, I like to roll. And that means I'm going to move 70 over to this side. So let's subtract 70 from this side. So this is going to cancel and this is going to cancel. So that leaves me with 23, that's only me with 17 over here and 23x over here. All right, so now I can divide by 23, and I know that 17 over 23 is my value of x. And it does not equal -2, so therefore it works. So let's do another one. 6.2. So we have to solve two parts here. We have a, which is 3/7x, this is a, sorry, plus 2/5y equals 11. So obviously we have an x and a y. We're going to be solving for both. B, so this is a system of equations here. This did not do right. I have 0.03x minus 0.2y equals negative 0.37. So I need to get these to where they are in whole numbers so that they'll make sense and we can solve them, right? So let's attack A first. I have 7 and 5. That's going to be 35, right? So 5 times that's going to be 15x plus 14y equals 385. I believe that's correct. Yes. So that's A. And then the second one, we're just going to multiply everything by 100 so that we can get rid of decimal places, right? So that would give us 3x minus 20y is equal to negative 37. All right, so now we have those two equations that are set up for us. And we are going to look at what we need to do to solve for x and y now. And we're going to use elimination. We're just going to multiply this times negative 5. So easy peasy. I'm going to rewrite this over here. A is 15x plus 14y equals 385. And then I'm going to write B after I multiply it. So negative 5 times all of this. That's going to be negative 15x. And that's going to be positive 100y is equal to positive 185. All right. So now we can do some elimination. We can eliminate that. And we have 114y is equal to 570. So when we divide both sides by 114, y is going to be equal to 5. All right, so now we know what 5 is, so we can go back in and substitute it. I think I'm just going to use this one. So 3x and 5 times 20, that's minus 100, is equal to negative 37. So 3x is equal to 63, which means that x is equal to 21. So now I have my x and my y value solved. All right, so same thing that we have been doing before in Algebra 2. Not super hard. So let's talk about some radical equations. I'm going to clear the board. Radicals in equations can be eliminated by isolating the radical on one side of the equation and then raising both sides to the power that will eliminate the radical. So let's solve 6.3 to show how this works. So we have something to the third root here, and that is x minus 5 minus 2 is equal to 2. So the first thing we're going to do is we're going to add 2 to both sides so we can isolate the radical. And that gives us the cube root of x minus 5 is equal to 4. Now we're going to raise both sides to the third power. And all that means is we're going to do this. That will make these two cancel out. So then this becomes x minus 5. And this becomes 64. So when we add 5 to both sides, x is equal to 69. Not super hard. We just have to remember what to do when we see these radicals. We just have to remember that the opposite operation or the inverse operation for a radical is the exponent. If we can pair those together and we keep that straight in our head, then that's going to be fairly easy for us to do. Now we can check that just to make sure. If you're not, you look at the answer and like, I don't know, you can always insert it and double check it. So here we have the original problem. I'm going to put 69 in for x. Minus 2 is equal to 2. Again, we're going to add 2 to both sides because we can, because that's how we do that. So then we get the cube root, and 69 minus 5 is 64, and that's 4. And we know that 4 times 4 times 4 is 64, so 4 is equal to 4. So that does check. So it's always a good idea, if you're not sure about the answer, you're not confident, go back and insert it. And if you want to just make sure your answer is right every time, that's a good way to do it. Just go back and take your solution and put it into the equation and solve. All right, let's do another one just to get some repetition in here and make sure we know what we're doing. Here's a little bit different type of problem. So we have square roots here, s minus 48 plus the square root of s equals 8. So, Ms. Tracy, how do we get rid of that? First, we have to isolate s minus 48. So we're going to subtract the square root of s from both sides. I know that doesn't look like the right thing to do, but it is. That's what we're going to do. So we have s minus 48 here equals 8 minus the square root of s here. So now we're going to square both sides. We're going to do this right here, and we're going to do this right here, right? Now when we square both of these sides, this goes away. So this side is easy. We don't have to do any math over here. But this side we have to do some stacking, and what we're going to end up with is 8 times 8 is 64. And then we have 8 times the negative square root of s, and 8 or negative 8 times the square root of s. So that's going to be negative 16 times the square root of s. And then, of course, negative square root of s times negative square root of s is going to be a positive s. So now we have this where we can manipulate it. So we're going to subtract s from both sides, which effectively eliminates the s. So then this is gone and this is gone. And now we're going to eliminate the 64 from both sides. So now we have on this side 112, negative 112. Yes. And that's going to equal the negative 16 times the square root of s. Now we can divide both sides by negative 16. Negative 16. I'm going to move this page up a little bit so we have a little bit more room. So this becomes 7 is equal to the square root of s. So if we square both sides, we find that 49 is equal to s. And we can always sub that in to make sure that's what s is. So let's do that with our original equation. So we have square root of s minus 48 plus square root of s equals 8, right? Now we sub in 49. 49 minus 48 plus 49 square root is equal to 8. 49 minus 48 is 1. Square root of 1 is 1. Square root of 49 is 7. 1 plus 7 equals 8. So it checks. All right, so that is what we just have to remember to do. We have to remember to isolate, square, isolate, square. And part of solving this is figuring out which one to isolate first and getting there. I would tend to isolate the more complicated or the more complex radical on one side like we did here. That way, the more simple one, we can multiply it more easily when we square this whole side. All right, think about that. Whichever one is the more complex, that's the one you want to isolate first. Knock that out. All right, let's clear the page. Let's talk about systems of 3 linear equations. So sometimes we have the sets of 3, and those can be solved by using either the substitution or the elimination, and sometimes both, right? So here is example 6.5. We have A is going to be 2x plus 2y minus z is equal to 14. B, 3x plus 3y plus z is equal to 16. And our third one is x minus 2y is equal to 0. So the first thing that I'm going to do is look for something that I can eliminate because it's the easiest thing to do, right? So I know I have a positive 2y and a negative 2y. So let's just get rid of that one first. Let's solve for that because there is no z there. So I'm going to say 2x plus 2y minus z is equal to 14. And x minus 2y is equal to 0. So I eliminate the 2y and I get 3x minus z is equal to 14. So there's my new equation that I can use. I'm going to write that up here. 3x minus z is equal to 14. All right, so now I need to solve the other one. Let's see if we can do this again. I'm going to use the first one and the second one, and I'm going to multiply by the opposite, right? So I'm going to say, let me get rid of this so that we have some room. We'll treat this like this is my scratch paper. So now I'm going to say 3 times this, and I'm going to say negative 3 times this. So that would be negative 6x plus, or minus, sorry, minus 6y plus 6z. No. That's what happens when you don't write it down. It's times negative 3, so that'd be 3z is equal to negative 3 times 14. I'm trying to do it in my head, and that's not really going well. 42, negative 42. So now I'm going to multiply this times 2, and that's going to be 6x plus 6y plus 2z is equal to 32. So both of these cancel. 5z is equal to negative 10. Z is equal to negative 2. So now I can actually substitute z in here. So that would be a positive 2, which allows me to solve 3x is equal to 12, x is equal to 4. So now I have 4, I don't know what y is yet, and I have negative 2. Right? So I used elimination to get here, elimination to get the solution for z, which allowed me to find x by substituting it in here. So using both, in conjunction with one another will help you to solve these. Now all I need to do to solve for y is I'm going to use this last one here, mainly because it is the easiest, the least complex. There's only the 2 variables. So I'm going to substitute in 4 minus 2y is equal to 0. So negative 2y is equal to negative 4. Y is equal to positive 2. And let me double check my solution, and that is correct. So we used elimination twice, we used substitution twice, and we were able to solve it pretty readily. And again, it doesn't matter which ones of these that you combine for elimination, just so long as you can pull the relativity of the terms together. You want to find the like terms. And remember, we did this one and this one first just because it was already set up for us, even though they didn't have the same number of terms. That's perfectly fine. You just need to put that to the side. once you solve for that so that you can use it for substitution later, because it is a valid equation once you've done that. So our answer was 4, 2, and negative 2. Let's do one more, just for practice and funsies. Let's do 6.6. And we have, here's A. Man, my pen is skipping. I must need to get a new tip to put on it. Here's B. And here's C. All right, so I think what I'm going to do is use the top 2 because I have a way to eliminate for Z first. So let me do that here. X plus 2y plus Z equals 4. 2x minus y minus Z is equal to 0. Z's are eliminated. I have 3x plus y equals 4. So there's one that I can use for substitution or for some other purpose. All right. So let's see what I can get. Let's look at the bottom 2. I think I can combine those. Z's are eliminated, and I have 4x minus 3y is equal to 1. So now I have that there. So let's try multiplying here by 3. So that would be times 3. That'd be 9x plus 3y is equal to 12. So then now these would eliminate. I have 13x is equal to 13. So x is equal to 1. So there's my x. So now I can go back and substitute in x for something. And I think what I'm going to do is just use my original up here. 3x plus y equals 4. So 3 times 1 would be 3 plus y equals 4. Y is equal to 1. All right, now I can substitute in y and x. I'm just going to use the one on the bottom because it's got the easiest access. 2 times 1 is 2, minus 2 times 1 is 2, plus z is equal to 1. So 2 minus 2, that cancels each other out. So then z is equal to 1 as well. Easy peasy. All right, and that's all we have for lesson 6, just a review and refreshing of radicals and systems of equations. And if you have any questions, let me know. I'll see you in lesson 7.